Bismillahirrahmanirrahim. Assalamu alaikum, guys. I'm trying another medium today, so hopefully, this recordings will be a little bit better, inshallah. First of all, welcome back to the next class. I think this is our third online class, our third online video that we're going to share with you. So for you all today, you are doing volume of cones, as you see on my board. A word to keep in mind is the word conical. So whenever you read the word conical, it refers to a cone. And it's a little bit similar to volume of cylinders. Just remember that in this case we have a cone, and the base, again, the base is a circle. So therefore, if you look at the formula on the board, you're going to be seeing that it has a lot of similarities back to the formula of a cylinder. The only difference is that it has 1/3. So formula for volume of cone, volume is equal to 1/3 BH. Now, why is it the 1/3? So basically, guys, if you have a cylinder and a cone, all right, of the same height, if I fill this cone up with, let's say the top was off, and I filled it up with sugar or sand or any type of, a material that I can fill it up completely, if I pour it into the cylinder, the amount that I can fill into this cone will only fill up 1/3 of a cylinder. So therefore, that's why we have the 1/3 on that formula. So again, don't forget that the base, or the capital B, is area of the base. The capital B in this case, because it is a cylinder, okay? Remember, it sits on a cylinder, although we use it many times this way, right? But it's still considered that the base is a circle. So therefore, it's the area of a circle. And again, we learned from the lesson on volume of a cylinder that the base, the area of the base would be pi r squared. So we break down the volume formula. Volume is equal to 1/3. Don't forget the capital B is pi r squared, and then don't forget that the h is there. So you're going to use all of this in order to figure out the volume. So let's turn a little bit this way, and here we go. So your instructions are to determine the volume. You're going to round to the nearest tenth, and you're going to be using 3.14 for pi, and I hope that you all can see it clearly. Now for this problems, I'm not asking you to answer in pi, although we could answer in pi. I just want you to go ahead and round to the nearest tenth. So let's get started with the first problem. Let's say that we have a cone, and the way you draw a cone, make your little almost triangle, and then put a curve in it. And then on the inside, to make it 3D, put a little dotted line on it, a little dotted arc. Now, you have to be given whether it's the radius or the diameter. In this first problem, I'm going to be working with the complete diameter, the whole distance across that circle. And the measurement here is 6 inches. Now, when we're talking about the height, the h, right, we're talking about the height of the cone. Now, usually, you will see it in a dotted line, and it goes right down to the middle, and you will be able to see a little box that tells you that it's a right angle, and this is where you end up finding the height. And in this problem, the height is 4 inches. Now, I'm going to show you one way, especially for those of you that have a 4-function calculator, and then another, basically the same way, but just with shorter steps, inshallah. So remember, we start with V is equal to 1/3, capital BH. Volume is equal to 1/3. Remember that we said that area of the base is that circle. So area of a circle is pi r squared. And then don't forget your height. So we have the information here, we have diameter. So what I need to do to the diameter in order to get my radius is going to be basically the 6 inches divided by 2. So my radius is going to be 3 inches. That's what I'm working with. Come back and plug in all the values that you know. Volume is equal to 1/3 pi, and then the radius is 3 squared. The height of the whole cone is 4, and then start doing your math. So 1/3 pi and then 3 squared. Remember, we go by order of operations, especially those of you that are using a 4-function calculator. 3 times 3 is 9, and then 4. You can go ahead and multiply. Remember that here you can move numbers around, obviously, because everything is being multiplied. I'm going to keep that as is for right now, 1/3 pi. I'm going to go ahead and multiply the 9 times 4. 9 times 4 is 36. Now, you don't have to do this step, but just to give you a frame of reference where our numbers coming from, remember we can use commutative property, move numbers around, and then still, I haven't even used a calculator yet, notice that. So I'm asking myself, what is 1/3 of 36, or we can say 36 divided by 3. So volume is equal to, go ahead and, if you have your calculator, go ahead and calculate it if you're not a mental math person, but that's what we have right there. Now, if you were asked to answer in pi form, this would be pi form right here, although I'm not asking for it, and I would just go into inches cubed. So it is possible to write in pi form even when you're finding the volume of a cone. So here we go, volume is equal to, next step, 12 times 3.14, and then volume is equal to, multiply 12 times 3.14, it's going to give you 37.68. And remember that this is actually approximately 37 and 68/100ths. Now for the nearest tenth, remember that this is in the tenths place. This 8 tells you what happens to the 6, and since it is a number that is greater than 5, that 6 becomes a 7. So final answer, volume is approximately 37.7, and back to our monkeys and birds, it's inches cubed. So the final answer here is 37 7/10 inches cubed. So pretty easy. Yes, it's a little bit long-winded, but you notice that we didn't really use our calculator till way down here. Maybe some of us used it over here, that's okay, but the majority of us might have used it once we multiplied. So I have one more example for you, because that's the whole lesson of today. And if you haven't taken all the notes, or if you're watching the video and you're taking the notes after I finish the problem, go ahead and stop the video and write all your steps down so you don't miss any notes. All right? So here's the next problem. Let me erase the board. I don't like to write too much on the other board. I don't know if I shared with you all. I know I shared it with some of my classes, but it gives me a problem. It doesn't erase very, very well. So usually I just have the other board for, some notes. Here we go. We're using the same instructions. The only thing is now this is a paper cone, and the question would be, how much can you fill the paper cone with? So here's our paper cone. It's a little bit more narrow. Again, the dotted line in the back, and I'm working with radius now. Okay, and the measurement for the radius is 4 cm. And then don't forget that the height is always from the tip of the cone, and it's usually a dotted line, and it goes to the center, and it usually has the little red box on the inside as well, and that measurement right there is 15 cm. Now the question can be in a word problem. You have a paper cone and you want to fill it up with sand. How much sand could you fill the paper cone with? So the question here is, how much sand could you fill the paper cone with? And it is a question. So remember again, we're doing volume of a cone, guys. Formula, volume is equal to 1/3 BH. Don't forget to break down your B. Volume is equal to 1/3 pi r squared h. And in this problem, they gave us the radius, so we don't have to divide anything by 2 because the radius is ready for us. So volume is equal to 1/3 pi, the radius is 4, So therefore it's squared, and then the height of the whole cylinder, or rather, sorry, the cone, is 15 centimeters. Now go ahead and start doing your math. First thing, we need to do the exponent. So we've got 1/3 pi. This is 16 times 15. So this is where I'm going to change it up a little bit, especially those of you that want to avoid the long-winded, all the steps that we did in the previous problem. And this also works for a 4-function calculator as well. So the only thing that I ask guys is don't write the formula, substitute the values, and then just give me the answer. Show me that you know how to do your order of operations. That's the whole point. Now remember that when you are multiplying by a fraction, it's understood from previous years that when you multiply with a fraction, everything should be in fraction form. So even though the pi, 16, and 15 are not in fraction form, you can put that invisible one on the bottom and it became a fraction. So all the numerators get multiplied together, all the denominators together. So our next step is this. 1 times pi, I'm not going to write the 1 down, but I am going to put pi. And since we already know that we're going to multiply for the next step or what have you, instead of just writing the symbol for pi, let's go ahead and put 3.14 right now. So this becomes 3.14 times 16 times 15. All right, and then I think there's a little bit of a glare on it. I'll move it so you can see it a little bit better. At this point, don't forget that we have the denominator, 3 times 1 times 1 times 1 equals to 3. So on a calculator, you can actually put 3.14 times 16 times 15 divided by 3, and then push enter. So all in one step, 3.14 times 16 times 15 divided by 3. Go ahead and do that. And you should get, volume is approximately, remember because we are multiplying by pi, all in one shot, you should get 251.2. So at this point, since it did say to the nearest tenth, we don't have to apply anything else to it. We don't have to apply the hundredths place. It's already in the nearest tenth for us. And don't forget our monkeys and birds, we're talking about centimeters. So it's centimeters cubed. So inshallah, this lesson will be much easier for you all this time from the composite figures. Although I will say that we do have composite figures even in this lesson. So I'm still contemplating, are we going to work on it or we'll just do it as extra practice somewhere along the line, inshallah. So I hope you enjoyed the lesson. I hope you found it easy. And if you have any questions, don't forget to sign in on class in the morning and ask any questions that you might have, whether it's in relation to the lecture or if it's in relation to the assignment that you received, or also the previous assignments, guys. Those of you that are not making it to class, although you're answering the attendance question, and I appreciate that, remember that